So before we really get started with the course, I figured we should start with some motivation. Why would a mathematics student want to learn how to program? Well, if you study mathematics at the university level, there are three possible careers ahead of you. The first one is in the industry. You might be working in the financial industry, you might be working in the pharmacological industry doing statistics, etc. Second possibility of a career is in mathematical research, and a third one is teaching. You might be teaching high schoolers, for instance. In either of the three, programming is very important. So let me explain that to you. If you work in an industry, well, it's very likely that computers have changed that industry in the very recent past, or are about to. Basically, it's always the same thing. Someone has an idea, and then it needs to be implemented. So some software needs to be written to implement that new idea. If you have experience programming, that would be a tremendous advantage to any job offer. Actually, it's even worse. If you don't have experience programming, it would be a huge disadvantage. The second point is if you do math research. Well, in that case, computers have a role to play as well. You could use computers as experiments. You basically have an idea and you immediately test it with your computer. This is an approach that's being more and more favored, even in pure math research. There's also another another application of computers in math research, and it's in computer algebra systems. So it's basically what I just said. You perform experiments, but at a higher level. You have access to more things that are specific to mathematics. So the canonical examples would be Mathematica, MATLAB, or Sage. Mathematica and MATLAB use their own language, but Sage uses Python. Finally, if you're teaching high schoolers, well, you're teaching kids that will grow up and eventually become adults in a world where computers are even more important. So maybe in that case, it's even more important that you know how to program so that you can actually teach it, and it's required for some math teachers. Okay, all this being said, the importance of computers in modern life and all that, I'm never advocating that computers are substitutes for thinking. That's what you get out of your math degree. You show that you're able to think and to think deep. What the computers do is that they help you leverage that thinking into the actual problems you're looking at. They help you make more out of that thinking. But it's still a skill. It's still a skill that is difficult to acquire, to be able to apply this math deep thinking into a problem. And that's why most of the directed work in this course will be in mathematics. I'll ask you to implement actual mathematics. So that's all fine. But in the projects, you'll have more freedom. You'll actually be able to choose projects that have nothing to do with mathematics, and that will be actually actively encouraged. And that's the nice thing about Python. It's really very general purpose. You can do a lot of different things, and that means you can then later sell it to more companies or use it for doing just other things that have nothing to do with math as well. That's not possible with MATLAB or Mathematica, for instance, where you have a very restricted domain of application. So how can we achieve all this? Well, let me outline the very general goals for the course. The first goal is to learn about basic programming concepts that apply whenever you program, whatever the language. So that will be useful if you then turn out to need another programming language. The second aspect is Python itself. What's the syntax and what are good practices when you're actually programming in Python? And the third aspect is in the translating mathematics into programs. How do you do that, and how do you approach that type of problems? At this stage, it would be good to tell you two things. The first one is how the course will be run in general. So what should you expect every week to happen, and what is expected from you? And the second one is that it would be nice to give you some example Python script so that you get some feeling of what a Python program actually looks like. Now, for the second one, it doesn't really make sense to make it too formal because you have no experience with Python yet and you will need to acquire it in the coming weeks. But still, it would be nice to give you some very informal example of what a Python program would look like. So what I'll try now is to do both at the same time. I'll try to give you some Python outline of what the course will be like and how it will be run. Okay, so here you can see my script, and it's 28 lines long, and everything that's in gray, like here, is a comment. and you'll see that it starts with a hash mark to indicate that it's a comment. Okay, so the first thing I do on line 3 is to import two external modules that of course don't exist because this is completely informal. And I just do it to indicate that first, this relies on the edX platform that we're using now, and also that this is really, as I said before, an experiment. So I'm really trying something new. Okay, so this is just providing some context for what will follow. So what follows is a definition of a function that I've called mat101, and this function will be applied to the set of students, all the students in the class. Now here is another comment, but slightly different. It's documenting this function, and it's called a docstring. So what does this function do? Well, it teaches Python to students, as I just said, and it tells you a little bit more. It tells you about what it's assuming from the input, and the input here are the students. So it will assume the students have some humor and some patience, because really this is an experiment. So things will go wrong, and I hope you will tell me when something goes wrong and that you will be lenient and wait for it to be fixed. Okay, so what's the actual body of the function? What will actually happen in that function? What will actually happen in the course? Well, here you see that the whole body of the function is indented. So this helps indicate over what range of lines the body of the function extends. Okay, and the first line, which actually will create a new block that spans the whole function, is with the assistance of peers and instructors, the following will happen. So this is important. It's providing you some additional context for all the body of the function, and it's saying that everything that happens in the course, for everything that happens in the course, don't ever forget that you have assistance from the instructors and from the peers. And you can get this assistance from the discussion forums. So if you're lost, you can always ask questions there, and they'll be answered by the instructors if a student hasn't already jumped in and answered the question. Okay, so that's an important aspect. You're never lost. You always have the discussion forums. And if it's really a problem for you to actually reach out through the discussion forums, there's also exercise sessions where you will meet with the assistants. Okay, so again, there is further indentation starting on line 10 and finishing on line 26 again. So everything that follows will happen with this extra context of assistance from the peers and instructors. I should say actually, so all the things that happen in this light orange, that are written in this light orange, are keywords that are recognized by my text editor and that are Python keywords. So I've written with, but this is actually a real Python keyword. So you see that Python gets very close to natural language, natural English language. Okay, and same thing for 4. So for every week in the range of 14 weeks that we have ahead of us, so every week you should expect the following to happen. Now we have a smaller block because everything that's after this block, but within the body of the function, is actually things that have to do with the final project. So this last part from line 23 to 26, well, it will happen with the assistance of the peers and the instructors, but it will only happen once, as opposed to everything between line 11 and line 23, which will happen every week. Okay, so what should happen every week? What's your week-to-week routine that should set in? Okay, well, the first call is a call to the function map. Now, map takes as input, this is a real Python keyword again, takes as input a function and some list to apply this function on. And then it will apply this function to each item of the list individually. Okay, that's an important concept. So here the list is the list of students. And the function is some video instruction corresponding to that week. So what I'm trying to convey here, informally again, I remind you, informally, is that every student, it's every student's individual responsibility to watch the video instruction of the associated week. And that's a good thing. It's more responsibility on you. You have to watch the video. But at the same time, if you are of some knowledge or if you understand things, you're welcome to do it at your own pace, meaning you can skip some parts, you can go faster over some parts and all that. If you you're of course also welcome to just follow it at the natural pace. Okay, so this is an important function, map, and it tells you, I repeat, it tells you that every student should individually watch the video instruction. Okay, it's not just video instruction though. There's also quiz assessments that are built in on the platform. So every week there will be quizzes that are more or less directly related to the video actually, and that will help each individual student assess directly whether they understood the video. And similarly with the homework, except that the homework will be a bit more heavy, a bit more complicated. It should take you a bit longer. The quizzes should only take you a minute, while the homework will probably take you half an hour each. Okay, so we have now 3 maps that we've just seen, the videos, the quizzes, and the homeworks, and this is followed by a call to reduce. Now reduce is also a Python function, and it's very common to make a few maps and then follow them with a reduce. What does reduce do? Well, usually it aggregates the output of map. So for instance, if you wanted to compute the occurrence of pairs of letters, successive pairs of letters, in words on average in all books that are written in German, well, you would look at this average for each individual book. So that would be a map. You would count the average for each individual book. And then you would reduce it by averaging the averages over all books. So this might sound familiar. This is similar to what Google is doing for a lot of its algorithm. And actually they invented the MapReduce programming paradigm, or they are using it extensively actually. So I'm trying to do kind of something similar here. I would like you to watch the videos, do the quizzes and the homework each individually, and then on the discussion forums, I would like you to aggregate this knowledge. So help each other with the knowledge you've gained from doing the previous things. Okay, now if this is not clear, maybe this is not clear, but you'll see it as the course goes, that the forums are actually an important part of it, and please use them. Now, after that, there is a test, and the test is a programming test, not an exam. So the programming test is if the week is greater than 5. So after a certain number of initial weeks, something different will happen, something additional will happen every week. And this additional thing is that you will be expected to form teams of 4 students, except the first of those projects will just require teams of 2. Okay, so you will be required to form teams of 4, let's say, and for every team, I'll expect a project. And I'll give you some guidance, of course, on how to do that project and how to choose a topic and all those things, how to actually do it and all that. Now, if you look, I've written here new grouping. So I'm expecting all the students to bunch up in groups of 4, and that will form the teams. But there is a catch. From week to week, you will have to change the groupings. You're not allowed to be in the same group as anyone else you've been with before. Okay, so if A likes B or A wants to work with B, sorry, you will only be allowed to work together for one project. This is meant so that the groups rotate and the groups change a lot and students learn from each other more effectively. Okay, so you do all this, you produce a new project, and then additionally so this, I have made a mistake here. This should really only be done once you are past week 5. So it should be indented, and it should be indented here. So what I would like is for every student, so every student, it's again a map, every student should look at the projects that the other students have produced and should assess the quality of those projects, should learn something basically from those projects. You might learn some mathematics if the theme of the project is mathematical, but you might also learn some programming. Okay? Then we're finally at the last part of this function, the one that's only executed once, and that part is that you have to do a final project essentially. And for this, again, there will be teams, and there will be teams of 4. Now, unlike over there where I required a new grouping, a genuinely new grouping every time, this time you'll be free to group however you want, except it will still be groups of 4. So this means you can reuse a pair of students in the same group. If you got along well with someone else, if you two work together very well, you're welcome to work together again on this final project. And every team formed in this way is again expected to produce a final project. Okay, so that's the function Math 101, and this function, well, should be applied to the students of 2013. So at the end, I call the function. You notice that this is not indented anymore. I call the function on the students of 2013. And together, we'll run through this whole course, this whole function, and we'll learn some Python along the way.